have my math module imported. That means whatever the functions that are there inside the math, so they are coming as part of here, because these functions are not part of the standard library. That is why we had to explicitly import this particular library. The very first function is fabs function. So in the integers, so from the standard library we have seen this abs function. Okay, so this abs function, what it does is, so it converts only integers. Okay, it converts only integer values into absolute values. So if you were to convert any decimals or any float values into absolute value, how can we do that? So with the help of this fabs function. Okay, and we can also use them to integers as well. Okay, and this can also be used for integers as well. I'll tell you what will happen if we use this function on integer. Okay, yeah. Let me have one variable which is minus 12.23. Let me have another variable 23.45. Let me have another variable which is minus 12. Okay, now if you could see, m1 is a float, m2 is a float, m3 is an integer. Now I will use this fabs function on all the these three. Okay, first I'll go one by one. Print fabs function, I'll just pass m1. Oh, sorry. So whenever you import any library, we just need to call this function with the help of that library name, math dot. We just need to go by math dot. Okay, yeah. See, now 12.23 is the absolute value for this minus 12.23. Now I can simply use the same function for this as well. Print math dot fabs of m2. See, so either it is negative value or positive value, it will simply convert it into absolute value. Now what I will do for the integer, okay, now what I will do for m4 is equal to math dot fabs of m3. I'll print m4. Now if you could see, m3 is an integer, right? Okay, now when I use this fabs function on m3, let us see what is the output type. Now the output got printed as 12.0, which, what is the data type for this, for such a kind of data, which is float. If you could see here, m4 is a float. That means what we can conclude from here is, it can take any type of numerical value. So it can take integers or decimals. Okay, but always returns float value. Okay, so even if you pass integer or float, it will always return a float value. So that we need to be very sure. So whenever we are calling this fabs function with integers, so that time you should be sure that you expect an integer or a decimal value. Okay, yeah. Because in Python we really don't explicitly define the data type, right? So it internally converts the data type without user intervention. So that is why we just need to be extra careful whenever we are dealing with such a kind of functions. Wherein integer can easily be transferred into any other type of data. That means obviously the float type. Okay. Yep. And just like after this fabs, we have seal and floor functions. Okay. Seal function and floor function. Let me first explain seal function. Okay, seal function and floor function. So these functions are specifically for the floats only. Float data types, because so a float data type is something between two integers, right? Let's say this 12.23. Let us take 12.23. 12.23 is a decimal value between two integers, which are 12 and 13. So 12, in between 12 and 13 we have 12.23. And if you were to find what is the seal value for 12.23, seal in the sense the next integer. What is the next integer for this 12.23? 13. Okay, that is the seal for this. And floor means the one which is like a behind. the very behind value. Okay, the integer which is smaller than this, and the integer which is greater than this is the CL value. That's in simple words. Okay, the next integer which is greater than this particular float is called as CL. Okay, it returns that value. And floor function also. Less than the float or decimal. Okay, now let me call this function on this m2. Okay, because this is a positive integer, so that would be very much easy to understand. Print math.ceil. So if I call ceil on this m2, what is the next big integer for this 23.45, which is 24. Now 24 will be printed for us whenever I call the ceil function on this m2. That's it. And similarly, if I call this floor function on this m2, it will simply return 23. That's it. Okay, 23, and we got 24 as the ceil. That's it. Now let me call the ceil or floor function on m3. See, m3 is already an integer, so that means I just wanted to like show you. So this function can take integer as also input, but even though if you pass integer, so there is no difference, because the ceil and floor are only for the purpose of dealing with the decimals and floors. That means you can always you have a use case wherein you always want to find a ceil or floor for the decimals only. There is no such a case that you will find such a case of integers, because integer itself is an integer. Okay, yeah. Now we know, see here m2 is a decimal value. What is the output of this ceil or floor function? So these are the integer data types. So from that what we can conclude? Returns integer. Okay, so this return integer. That's it. Okay, we just need to be sure about what is the return type of return data type. For FAPS, it is always a float. For ceil and floor, the input parameter, I mean the input data type that we need to pass is a float type, but wherein the return type is an integer. Okay. Yeah. Next we have this exponent function and the square root functions under this math library only. This exponent function, so we know exponent function, what is really an exponent function is. So exponent function is something e to the power of something like that. So base is always e. Okay, and we just need to pass what is the exponent for this. That's it. It will perform e to the power of some value. Okay. If I want to find e to the power of 1, that means obviously e. So let us see what is the value of e. We know value of e is 2.718. That's it. Okay. Yeah, if you were to find this e to the power of something, if I want to find e to the power of 5, I can simply call such like that. Math.exponent of e to the power of 5. That's it. It will simply perform e to the power of 5. And next function is the square root function. So this is the function in sqrt. So to which we just need to pass what for which you want to find square root. Okay. Yes, sorry. Returns the square root of a number. Now I want to find the square root of 144. Now let us see how the output is printed for this. The output is printed in the form of a float. That means So it can take, let me pass a float as an input. See, this square root function, okay, the input parameters, it can be of both integer and float data type, but the output is always float data type. Okay, that is the only thing we just need to remember. Input can be integer and float, okay, or float, but always returns float data type only. Okay. Yeah, these are some important functions I just want to bring to your focus. There are like many other functions, whatever you want to like achieve in the mathematics, we have the sine functions, trigonometry functions, algebraic functions, even the quadratic formulas. Everything is available under this math module, but that is not really useful for us. Okay. Yeah, I just gave a few of the important functions, that's it, which we can use. Not only this not only specific to the mathematics, so this can also be used for a general purpose as well. Okay, in some of the problem statements that we can use, wherein you want to find a seal, floor, exponent, square root, and just like here, maximum value, minimum value, and power of this, and if you were to like round some float values into specific places. Okay, so these are some of the important built-in functions under the numerical literals that I just wanted to bring to your focus. Yeah, so yeah, there are many more functions. If you want to whenever there is a use case, you can simply refer to this math module. You can simply search on the math module, so you can simply check whether whatever the function that you are looking is available under this library or not.